Hello and welcome to today's class. My name is Francis Pelumi. I'll be your mathematics teacher for today. Okay, straight to the class. You're welcome once again. What you need to do is to take out your notes and get ready for what we'll be discussing today. Before we move on to the topic of today, I need to ask you, have you heard about index form before? Index form. Probably in your primary school, in your junior classes, index form. Okay, let me cite an example when we have 5 times 5 times 5. That 5 times 5 times 5 can be written as 5 raised to the power of 3. Okay, you are aware? That is it in index form. 5 times 5 times 5. That's 5 raised to the power of 3. That is it in index form. Alright, let's move on. Indices now. Indices is a plural form for index. Index, then the plural is indices. Indices are numbers expressed in powers of another number. Indices are numbers expressed in powers of another number. For example, 2 raised to the power of 5. In essence, you say 2 superscript 5 because we can call it superscript. In another way, we can call it as power, index, exponent. Even in computer, we have it as 2 cap 5. Yes, so it's 2 raised to the power of 5. But before we can solve questions on indices, there are laws guiding indices. So that's why we call it laws of indices. Laws of indices. We have the multiplication law, the division law, the zero index, power law, index, negative index, fractional index. So let's start with the multiplication law. When we are having a raised to power m times a raised to power n, it will be equals to a raised to power m plus n. But I need to say something to the usage of this law. The basis must be equal. Like now, when we are having a raised to power m, a is the base and m is the power. A is the base and m is the power. Likewise here, a is the base, n is a power. So they must have the same base before you can apply this law. So a raised to power m times a raised to power n is now equals to a raised to power m plus n. When they have the same base, you add the powers together. So that's why the multiplication law is a raised to power m times a raised to power n equals to a raised to power m plus n. Is that clear? Okay. Let's move on to the division law. When we are having a raised to power m divided by a raised to power n, it's not going to be a raised to power m minus n. Here you are subtracting the power. Remember, they must have the same base. A raised to power m divided by a raised to power n will be equals to a raised to power m minus n. You subtract the powers when it is a division. Now, the zero index, zero power, 0 degree, yes, when it is raised to power 0. Like a raised to power 0 is 1. To tell you that any number or maybe letter raised to power 0 is equals to 1. So that's why we're having a raised to power 0 is equals to 1. Even though it is 1,000,000, raised to power 0, it is still 1. Am I clear on that one? All right. So let's move on. We have another law, the power law. The power law. Here, we are having a raised to power m in brackets raised to another power of n. A raised to power m in brackets raised to another power of n. This one is now equals to a raised to power m times n. A raised to power m times n. What are we saying in essence is that When you're having a power to their base and it's being raised to another power, what you need to do is just to multiply the power together. Am I communicating? All right, let's move on. We're having negative index, negative power. When you're having it as negative power, what I'm having is a raised to power minus m. A raised to power minus m, negative index, a raised to power minus m will be equals to 1 over a raised to power m. It will be the reciprocal of what we are having when we are having negative power. We are having negative index. So it's going to be a raised to power minus m as 1 over a raised to power m. Okay, when you still get to understand it better when we start solving examples on that. A raised power minus m equals to 1 over a raised power m. Now we move on to the last law on our screen here, fractional index, fractional power. When the power is now a fraction. This is a raised to power m over n. Okay, it's written this way, the mathematical term to be able to raise it as a power that way. So just manage that. A raised to power m divided by n will be equals to nth root of a, nth root of a, close bracket, raised to power m. What are we saying here is that when you're having a raised to power m over n, it's going to be, you find the nth root of a, of the base, then everything raised to power m. When we start solving question, you see it better. So that is about the laws that we are having here. So can we move on? All right. Examples now. Let's solve some examples. Let's talk about examples there. Write down the values of the following in index form. Write down the examples of the following in index form. We have question 1. 7 raised to power 6 times 7 raised to power 2. 7 raised to power 6 times 7 raised to power 2. 7 raised to power 6 times 7 raised to power 2. Now, this is the solution here. So let's solve it. So, I will pick the first example. We come here to solve it. Then we move on. We move back to the second example. Let's solve them step by step. In that question one that we are having 7 raised to power 6 times 7 raised to power 2. Remember I told you from onset, before you be able to apply the law, they must have the same base. Here the base is 7 for the first one. The base for the second one is also 7. They are equal bases. So 7 raised to power 6 times 7 raised to power 2, using the law of a raised power m times a raised power n will now be equals to a raised power m plus n. So that is 7 raised power 6 plus 2 equals to 7 raised power 8. Am I communicating? All right. Is it clear? Any question? Okay. So let's move on to the second example. The second example is 5s squared times 4s raised to power 0 times 2s raised to power minus 6. I repeat, 5x squared times 4s raised to power 0 times 2s raised to power minus 6. In it, we solve it this way. We first multiply the coefficient. Then, okay, why do we call it coefficient? The number multiplying the letter is called the coefficient. So when we are saying 5s squared, the coefficient there is 5. So you first multiply the coefficients. The coefficient for the first one is 5, the coefficient for the second one is 4, and the coefficient for the third one is 2. So we first multiply them out. 5 times 4 times 2 is 40. 5 times 4, 20 times 2, 40. We first multiply. Then the exponent, the power, I told you index can also be called power, it can be called exponent. For the exponent, We are having power 2, power 0, and power minus 6. It is multiplication. You can add the powers together. Since it is multiplication law, you add the powers together. So that is 2 plus 0 plus minus 6. 2 plus 0 plus minus 6. 2 plus 0 is still 2. Then 2 minus 6 will give us minus 4. So that's why the answer is now, you remember we have multiplied the coefficient to be 40. Now the power of x is now minus 4. So we now write that 40s raised to power minus 4. 40s raised to power minus 4. And that s raised to power minus 4, that is negative index, negative power. That will now be 40 over s raised to power 4. 40 over s raised to power 4 because it is having a negative index. Now, move on to question 3. Up, down, okay, oh, is question 2 clear? All right. Now, question 3. 16r raised to power 11 divided by 4r raised to power 7. 16r raised to power 11 divided by 4r raised to power 7. Yes, that's the third question. Okay, we move on to the solution. We divide the coefficients. Remember, the first deal with the coefficient. This 16 and this is 4. So 16 divided by 4 is 4 as the coefficient. It is division law. And remember, when we are having division law, you subtract the powers. That is 11 minus 7. The power to the first one is 11, the power of the second one is 7. So 11 minus 7, which is what? 4. So we have solved for the coefficient, which is 4. Then the exponent or the power is now 4. So the answer is now 4 raised to power 4. 4r raised to power 4. 4r raised to power 4. Is it clear? Okay. All right. Now, any question? Okay. So let's move on to number 4. So let's look at number 4 together. 8 over 27, everything in brackets, raised to power minus 2 over 3. 8 over 27, everything raised to power minus 2 over 3. So let's look at the solution. Now, if no, let me explain this better before we move on to the solution. You can see the base is now a fraction, 8 over 27. For the power, we're having fraction as our power and we're having negative. So we're having a negative fractional index. 8 over 27 raised to power minus 2 over 3. So remember, this one, when we are having negative index, negative power, is taking the reciprocal. So when we now take the reciprocal, so first we take the reciprocal for the negative power, the negative exponent. And when we take the reciprocal, that is 27 over 8. You know, it is 8 over 27. When you take the reciprocal, it will be 27 over 8. There, it will deal with the negative. It will now be 27 over 8 raised to power 2 over 3. It will have taken care of the negative. So, we now apply our rule. That, 27 and 8, they are both sharing the power. 27 is also going to be raised to power 2 over 3. 8 is also going to be raised to power 2 over 3. When you now apply the law that when we are having fractional index, you first take the cube root of 27, which is 3, raised to power 2. Yes, yes, 27 raised to power 1 over 3, and that would be the cube root of 27. What's the meaning of cube root? A number that you multiply by itself 3 times, that will give you the number given. You find a number to multiply by itself 3 times to give you the given number. So it is the cube root of 27 is 3, then square, that is 9. Then you move on to the denominator, which is 8. I told you they are sharing the same power. That is 8 raised to power 2 over 3. You also find the cube root of 8, which is 2. because it is 2 times 2 times 2 that will give you 8. So the cube root of 8 is 2, then raised to power 2 that is outside, then 2 raised to power 2 is 4. We have gotten for the numerator the answer to be 9, and the denominator the answer is 4. So the result is now 9 over 4. Is it clear? Okay. Is it clear? Any question? Or do you want me to go over it again? Said you first take the reciprocal because we are having a negative, a fraction, negative index, and it's also a fraction. You take the reciprocal of the base. That is 28 over 27 now, 27 over 8. Raised to power 2 over 3, having taken care of the negative. We now split them. They can be splitted. 27 will take the power 2 over 3. 8 will also take the power 2 over 3. 27 raised to power 2 over 3, you take the cube root of 27, then raise it to power 2. I told you the cube root of 27 is 3. A number you multiply by itself 3 times to give you 27. That is 3. Then 3 raised to power 2 is 9. And the denominator, which is 8, raised to power 2 over 3 now, you first find the cube root of 8, then raised to power 2. What's the cube root of 8? Is 2. A number you multiply by itself 3 times. It is because it is 2 times 2 times 2 that gives you 8. Now 2 raised to power 2 is now 4. The numerator, the answer, the result is 9, and the denominator, the answer is 4. So the result is now 9 over 4. Am I communicating? All right, let's move on. Oh, beautiful. So what did you learn from the previous slide? Okay, you learned the application of the multiplication law, the division law, the negative power, the fractional power. Can you now apply the rules in your evaluation? Like I want to give you a practice question. But for the practice question, you need to click on the link on this. When you click on it, it's going to lead you to some questions on way ground. Yes, yes. When you click on it, it's going to lead you to some questions on way ground, which you solve at your own pace. The questions are still based on indices, on what we have learned so far. So it's just for your practice. So when you click on the link, it will lead you to the questions for your assessment. Any question? Okay, okay. So do you understand what I asked you to do? You click the link, then it will lead you to some questions based on the topic that it's based on the parts of the topic that we did today. All right. So, okay, okay, let me give you a few minutes more. All right. Okay. So, look at it now. This is it. Drag your dot. How are you feeling? Should we continue with the class? Okay. Now, this is it. It's just for you to hear how you're feeling. The first one is keep going. I understand. That's the first image. Then the second one is, oh, I'm a little confused. If that one is your own feeling, so that one can know, okay, do you want us to go over a particular part of the class? Okay. And if it is the last one, stop, I need help. Where do you need help? The first one is keep going, I understand. All right. Yes. This second one, I'm a little confused. Where do you need clarity? And the last one is stop, I need help. So which one? So express your view in this thing. So thank you for joining the class today. Okay, you will keep on expressing your feelings so that we'll be able to know. Okay, good. You want me to? Okay, you're a little confused. You need a little clarification. All right. So for the clarification is just to go over the rules. These are the rules, the laws or rules: multiplication law, the division law, the zero index, the power law, the negative index, the fractional index. I know you might have a little confusion about the fractional index. So when you're having a raised to power m over n, it will be the nth root. That's why in the last example I was talking about the cube root. So nth root of nth root of cube root of 8, cube root of 27. Then after that, you now raise it to the power up here, power m. All right. Thank you for joining today's class. So just go on to your practice. All right. Thank you.